I need the hat. Statistics.
Hi. Welcome to our minisode about biostats.
Biostats.
Hello. Hi, Mab. Is
Hi,
that our
Mira.
intro? Hi, Mab.
How are you today?
I'm good. How are you?
I'm fantastic. I'm excited to learn about biostatistics.
Awesome. Today it's me leading it.
Yeah,
Normally
for
it's
once.
you.
Yeah.
For once. For once it's me. So do you know what biostatistics is?
I would be lying if I said no.
Okay. Well, okay. Let's break it down. I don't need you to explain the whole thing. Bio.
Biology.
Correct.
Nice.
Which is?
The study of living things.
Correct.
Okay.
Okay, dictionary.
Nice.
And then what is statistics?
Statistics? See, that's where I get a little... It's using math to figure out if things are right or not. Right?
That's a way to say it, yeah. It's like, it's collecting a bunch of information and data and analyzing it to, like, figure something out.
Okay.
I feel like that's the way I would say it. Well, I don't know.
So then what's biostatistics?
So, well, we'll talk about it. I want to talk about statistics.
I love math.
Okay, so you do love math.
We're in a rocky spot right now.
Okay,
but yeah, I'd
it's a
say I
complicated
enjoy math.
relationship.
I like to think about math.
Okay. So, someone who does stats
Mm-hmm.
is a statistician. Statistician. It's a fun word. And all they do, well, not all they do, but the main thing that they do is they collect a bunch of information, and then they do studies and stuff to collect that information sometimes, or sometimes they just, like, observe things that are happening in the world, take all that information, all that data, and then they figure out what they can learn from that and apply it to different things. So, like, you've probably heard of probability.
Probably.
Probably.
I have.
That's a type of, well, it's associated with statistics, because what you're doing with probability is you're taking a bunch of stuff and you're going, oh, what are the odds that this is going to happen? Like, if you flip a coin a bunch of times, what are the odds you're going to get heads?
Like 1 and 2?
Yeah, 50-50.
Yeah.
Half the time you'll get heads, half the time you'll get tails. Probability.
Probability.
Type of statistics.
Okay.
Same thing, like, do you know about the thing where you roll the 2 dice
Yes.
and then you figure out what's the most common number rolled on 2 dice?
Is it like what? Like 7?
It's 7.
Nice.
It's 7. Because of math reasons.
Because of math. And that helps me in my everyday life.
Yeah. And that's what statisticians do. They take a bunch of information, like how many times you've flipped a coin and what you get each time. Like, okay, I flipped it once and it got heads, and then this time it was tails, and this time it was heads, this time it was heads. And then they combine all that information and they go, what can I learn about this? And they go, people do their thing. Leans in.
Tell me more.
They'll do studies, or they'll be hired by people to do studies to, maybe they'll try to make products better, for example. Like, if you're developing a new, I don't know, cereal, they'll be like, who wants to buy these cereals?
I do.
Mab wants to buy the cereals.
I love cereals.
They'll interview a bunch of people. They'll be like, does a child want to buy the cereal? Does an adult want to buy the cereal? Do old people want to buy the cereals? That's one way you can do stats, like in a commercial setting. But biostats is about, what do you think it's about? You know what it's about.
Well, like statistics about biology.
Yeah. So usually it's about health and medicine. But they can do all sorts of stuff. What kind of things do you think a biostatistician would do?
Well, if you're maybe collecting information about like a bird, is that biostatistics?
It is.
Okay.
It is. There's all sorts of types. They do things like, they use biostats for, like, farming genetics. Did you know this?
I didn't know
They
this.
collect a bunch of information about, like, plants and how they grow, and then they figure out, like, best practices for farming.
So we get some like real life applications from the data that we collect using statistics.
Exactly. That's the whole
Okay.
point of stats.
Gnarly.
Isn't that fun? What about in, like, a medical setting? Like, for human medicine?
So like maybe if you're testing like how efficient a drug is or something, like a treatment.
Yeah.
Like, do I want to take this pill to make my arm feel better, or do I want to go to like a surgery or something?
That's
Yeah.
a big one. Think of anything else? No?
No.
There's also, they use biostatisticians use statistics to figure out where, like, diseases come from.
Oh.
So, like, when the coronavirus happened, a lot of biostatisticians were working their way to figure out where it comes from, but also how it spreads. And a big thing was, like, the best way to prevent spread. Like, they would take all the information about different countries and how they dealt with COVID, and then they were like, what's the best way to do this so that in the future, if we have to deal with other diseases, big or small, we know how best to deal with it because of biostatisticians.
We take this big, juicy data set.
Yeah, all sorts of information.
And then we can apply it to, like, keeping people safe
in
countries. Cool. That's really cool. So is that, like, you know, like, during the peak of the pandemic when they were like, flatten the curve, is that, like, biostatistics?
It is.
Oh.
It is. Because it's all based on, I mean, all of, like, the amounts of people who have COVID and, like, how it spread and where it comes from was all something that was worked on by biostatisticians. It's biostats. It's stats about biology.
Sweet.
Isn't that crazy? Graphs.
These aren't, like, just, like, normal, like, little piddly graphs, are they?
All graphs are important. All graphs are equal.
Pie chart?
I love pie chart.
You love pie charts?
I love pie chart. Maybe I don't love pie chart. It's not a great way to display data. But if you've ever seen like a population chart where it's like or like in COVID they had like the spikes.
Yeah.
And that's why they were flattening the curve, because it was like rises in cases, but they wanted it to plateau and then go down.
This is the kind of math that I like. Math that, like, means something.
I know, I have a hard time with math sometimes, but stats is nice because it's, like, based on real observable things. Not that all math isn't, but, like, it's much more concrete. You're like, oh, I flipped a bunch of coins and I learned that 50-50 probability.
Yeah. I used statistics when I was in school to do, like, what percentage of a chance is it that this thing that I'm doing is causing this consequence. So that's how I used stats.
I like that. I actually never did stats in my degree. So.
It was kind of fun.
Yeah. I kind of missed out on it. I did different types I did calculus and linear algebra, which is not as applicable. Well, I mean, it is applicable in real life, but it's not as like, look around.
Well, it's applicable.
Linear algebra.
I mean, the cool thing is math is kind of everywhere.
It is everywhere.
Isn't that wild?
It's like a way of interpreting the universe. Like all science.
Like all science. Like all art, in a way.
Like the human experience.
The human experience is math.
It is math.
I think a lot about how pi is, like, just something that is true.
Yeah. I've eaten it many times.
Okay. Well, la-di-da.
How many digits of pi can you read?
I recall off the top of my head 15. Okay.
I want to see you do it.
Okay. 3.141592653589793238466.
Wow.
I didn't have a lot of friends in middle school.
I can only do 3.14159265355.
That's still more than, like...
I also didn't have a lot of friends in junior high.
That's so much kinship. And now we're both here.
When you did stats in college, did you use R?
I did use R. So R is a computer program used to analyze a lot of data and then pull statistics from that. So specifically, let's say I'm looking at, like, a plant and I want to know if, you know, this fertilizer is helping my plant grow or not. I'll have two sets of data. I'll have the plants where, you know, I added the fertilizer and the plants where I didn't add the fertilizer. And then I'll use statistics to compare those two to see if there's actually a difference.
That sounds like biostats to me.
It probably is.
It's about plants.
Yeah, biology.
And farming and biology. That's crazy. I just wanted to talk about R because...
Please talk about R.
Well, I've never used R, but I had a lot of friends in college who did, like, life science stuff and did it for their stats. And they would always ask me to help them, and I was like, I don't know how to do it. But stats is cool because, I mean, you can apply it to biology, you can apply it to, like, commerce, but it's also used a lot in AI. So, like, when you're creating an AI, like ChatGPT, basically it's just doing a bunch of, like, probability calculations to figure out, like, what kind of things you're asking it. So if you're like, hey, write me a story about a princess who gets kidnapped by a dragon. It'll be like, and it has all of this data, and it knows all these things because it's been fed a bunch of information, And it looks through all of it, and it goes, okay, so what kind of thing are they asking me? I think that they want me to put in this, based on all of these other stories that I've read that are like this. They're, like, narrowing down, and it's like, okay, they probably want this. This seems like something that the user is interested in. So it's based on, like, they just do a bunch of calculations, and it's based on proximity to what they think you want.
I didn't know that.
Isn't that cool?
That's really cool.
They do that with other things what's the word? Like, AIs that can recognize things. Like, if you've ever... I'm trying to think of an example.
Like, my Google phone is like, you're probably looking at a picture of this hat
that
you want to buy.
It'll look at it, and it'll be like, it could be this, 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 or this. Because it's a camera, it doesn't have a brain. It's just basing it off things it's seen in the past, like a big bunch of data. So it'll probably be like, well, it might be a polar bear, or it might be a white dog, but it looks way... But that's the limit, I can tell you.
I got a blanket in my nose.
Oh no, not blanket.
It's a good blanket.
My mom made it.
Oh.
Yeah, and also, like, predictive text is just...
Oh, like when I'm writing an email, it's like you
like,
probably want to say thank you.
Thank you, yeah. It's just based on, like people usually do this, so...
Like, there's a 90% chance you want to say thank you, and a 3% chance you want to say...
Yeah.
Poo-poo pee-pee.
That would be crazy if you said poo-poo pee-pee.
But I guess if you were always writing poo-poo pee-pee, the chance of you wanting to say poo-poo pee-pee...
Because some of them can learn from you, and it'll be like, oh, well, they usually type this, so we'll put in this. Because if you've ever, like, if you have, like, an Apple device, they'll learn sometimes what you say. And you'll, like, type in one thing that you usually say with another, and it'll be like, oh, you probably want to add this word. Like, someone's name, for example. It'll be like, I know this person's last name because you type their full name out a lot, so maybe they want to do first name, and then they're like, would you want your last name too?
So statistics sounds like it's everywhere.
It's everywhere. It's in everything.
Maybe statistics is the friends we made along the way.
Maybe it is. I also learned that, going back to biostatistics, I forgot to mention this, that biostatisticians also use a bunch of data to figure out whether or not things are healthy to us that aren't medical related.
Oh.
So, like, you know, when water bottles say BPA free, it's because they used to make them with BPA, and then they did a bunch of research, and they were like, huh, that's not good for people. So then they decided to take it out of plastics.
How do you get from, like, column A to column B? Like, how do you get from, like, people are unhealthy to BPA? Or is it like...
I think it's the other way around.
You look at BPA first, and then you go...
I think it's the other way around. There are, like, some things where it's like, yeah, I'm assuming that all these people who worked in this mine who have the same sickness got sick because of the mine, whereas I'm pretty sure for something like BPA or, like, the nonstick pan stuff that used to be on those that got taken off recently, I think, they're like, maybe we should, like, figure out if these plastics are bad for people. Like, I don't know if it's like, this person died from having an Nalgene. It's more of, like, a risk thing.
Okay, cool. Huh.
I don't know, though. I'm not a water bottle maker.
Yeah.
Big grain of salt.
That's a pretty big grain of salt.
Big old
That's
grain
a
of salt.
salt lamp size.
Salt lick sized grain of salt.
Cool.
So, yeah. Biostats. I don't know if there's anything else to say about biostats. It's
I
pretty
think
simple.
I learned a lot about biostats.
What did you learn?
Oh my gosh. Well, I learned about what biology is. I learned about what statistics are. And I learned about probability. And you've got a 50% chance of getting a heads and a 50% chance of getting a tails. And I learned about how biostatisticians work in a lot of different fields. We've got probably like pharmacy, health, agriculture.
They work with animals too, not agricultural settings.
Oh, just like...
If you've ever given your cat medicine, how do you think they figured out how those work?
Statistics.
Ugh. Biostats,
specifically. And I learned a little bit about R, and I learned that AI is probability based.
Yeah, some of it.
Not
all of it.
Okay.
Not all of it.
Where's that grain of salt?
It's this big.
Oh, it's getting bigger.
Giant grain of salt. Yeah.
Well, thank you so much, Mira.
Thank you for listening to me talk about stats.
Where can I go if I want to learn more about biostatistics?
You can go to our podcast where we interviewed Colin Vibert. You can go to our podcast. How do you pronounce it? I'm going to do that again.
Vibert?
Oh.
I think it's Vibert.
Okay.
So where can I go where can I go if I want to learn more about statistics?
You can go to our podcast. We interviewed Colin Vibert, who is a biostatistician.
Mm-hmm.
He talks about what he does. He works in pharmacy.
Yeah.
And he also works with coding. He works with R and stuff. So he talks a little bit about that too.
Gnarly.
Yeah.
Thank you so much, Mira.
Thank you, Mab. Big handshake.
We're trying something new.
We are. One mic, one handshake.
One mic, one
New
handshake,
bangs.
one heart. I like the bang.
Thank you. Yep. Statistics. Yep. Statistics. Yep. Statistics. Yep. All right.